Welcome students. Today in this video we are going to know about the super mesh analysis. Okay, you all know what is called a mesh. Now there is a special scenario during the time of finding solution of a circuit using mesh analysis may appear, which is basically solved using this super mesh analysis. Okay, so before going into deep, we must have to know what is called a super mesh. Okay, so super mesh is basically a situation which appears when there is a current source common to two meshes. Okay, means two mesh is having a current source in common. Okay, like this. Say this is a circuit. In this circuit, here there is a current source. Okay, and this is how the circuit completes. So what is happening? See, this is mesh 1 and this is mesh 2. Now this current source is common to both the meshes, means mesh 1 and mesh 2. Okay, so we can consider this as a super mesh. Okay, so I think from this the definition of super mesh is very clear. And to solve this kind of now to solve this kind of circuits, we need to use both KVL and KCL. Means we have to use both of these laws to find the solution of such kind of circuits. Okay, so now what we will do, we will try to solve a problem, and from that we will know that how to get the solution of such kind of circuits. Okay, so before that we just write here down a super mesh is formed when two meshes are having a current source as a common branch. Okay, and for finding the solution of such kind of circuits, we need to use both KVL and KCL. Okay, means we need to apply both KVL and KCL. So now let us have the problem from which we will learn how to find the solution of such kind of circuits. So here you see that there is a circuit containing voltage and current sources, and here we will develop the concept of super mesh. Okay, so from this circuit what we can see this source is common to both this loop and this loop. So definitely this is forming our super mesh. Okay, so now what we will do, we will just draw the circuit in such a manner that will help us to solve it by super mesh analysis. Okay, so let us redraw the circuit like this. Let us take this as the reference node. Okay, take this as the node 1 and this as node 2, and also take the voltage of this node as V2 and the voltage of this node is V1. Okay, so from figure 2 what we can write, V1 minus V2 is equal to 6 volts. Okay, because this is plus and this is minus. And also from this super mesh, okay, from super mesh, this is mesh 1, this is mesh 2, and this is mesh 3. Okay, having both mesh 2 and 3, we can write the KVL equation for that super mesh as what? We definitely have to take here one current, here another current, and here another current. Means this is I1, this is I2, and this is I3. Means I1, I2, and I3 are the mesh currents respectively. Now for the super mesh, what will be the KVL equation? Starting with 0, say here there is a source which is having 0 volts. What we can write? 0 minus 2 into I2 minus I1 minus 6, and finally minus 4 into I3 equal to 0. That means while considering a super mesh, the current source which is there as a common branch to both the loops, means mesh 2 and mesh 3, that basically disappears, and we are writing the KVL for this total path. Okay, this total path. Okay, so from this what we can write? We can write 2 into I2 minus I1 plus 4I3 is equal to minus 6. Means minus 2I1 plus 2I2 plus 4I3 equal to minus 6. And also from mesh 2 and 3, what we can write? We can write I3 minus I2 equal to 2 ampere. Okay. And from mesh 1, what we can write? I1 is equal to 5 ampere. Okay. So now just put here I1 is equal to 5. What we will get? We will get 2I2 plus 4I3 equal to minus 6 plus 2 into 5, means that will be equal to 4. That means I2 plus 2I3 equal to 2. Okay. So this will be one equation. I2 plus 2I3 is equal to 2, and another equation is I3 minus I2 is equal to 2. Okay. I3 minus I2 equal to 2 ampere, and also I2 plus 2I3 equal to 2. Okay. Now just summing them up, what we will get? This will cancel out, and 3I3 equal to 4. That means I3 is equal to 4 by 3. Now see, you have to find out the current through the 4 ohm resistor. Okay, current through the 4 ohm resistor. Current through the 4 ohm resistor is nothing but the current I3 that we have already calculated as 4 by 3 ampere. So the answer is the current through 4 ohm resistor is 4 by 3 ampere. Okay, I think this supermesh analysis and the concept of supermesh is understandable to each and everyone. So try to solve much more questions like this, then it will become comfortable for you to solve such networks. So thanks. If you like the video, kindly subscribe to the channel. Thanks for watching.